Corydon 76 on IRC, and this is our presentation for building Asterisk applications. Just want to let you know, as it says on the website, if you're not familiar with Asterisk, you'll be bored to tears. If you already know how to write Asterisk applications, you'll be bored to tears. So, I'm talking about dial plan applications themselves. So this is all in C. So if you don't know C, you'll be bored to tears. So I'm sort of expecting, like most of you, to get up and leave, and there'd be like 5 people left, and we'll have an intelligent conversation. But oh well. So just to go over a little bit for the Asterisk dial plan, we have a context. This actually is a real context. Our incoming context. We include 2 contexts, other contexts. Then we have the extension definitions, the extension, the priority, and this right here is the application itself. This is what I'm talking about developing. These are all standard applications: wait, set music on hold, answer, set bar, dbget, and go to if. We're talking about some of those things a little later. And these are just some of the applications in here. Some things I've actually worked on: absolute timeout. I haven't worked on that actually, but add queue member, the AGI stuff, the cut, which is mine, random, conditionally branches, say Unix time, which I developed completely, and we'll discuss this one. These 3, which you've never seen before because I haven't released them yet, these are what I'll be talking about a lot later because they're brand new applications that will get released to the community on Monday. And then, of course, there's voicemail. So I'll just go through the application skeleton. Every application is basically going to look like this. They'll have a whole bunch of includes for the various things, accessing files, logging, channel manipulation and channel structures, actual PBX routines like the variable setting, modules, which all your applications, unless you build them internally to Asterisk itself, everybody's going to use modules. Locking, which is really important because Asterisk is a multi-threaded application, and so there's a lot of opportunities for race conditions. And then we just have a few standards. We have a description for the entire, not necessarily the application, but the module itself. The name of the app, a synopsis, which you can view inline when running Asterisk, show application, few declarations. Here's the meat of the application skeleton. This is what actually gets executed when you call it in the dial plan back here. Again, this is just an overview. Unload module, what happens when you unload it. Basically, it's all it is unregistering your application. Since these are modules, the nice thing about in Asterisk about these modules is that not only can they be loaded at boot, but they can also be loaded later, and they can be unloaded after boot. So you have unload, load. This actually doesn't have a reload in it, but reload module is a standard. Description and use count. And use count is what determines whether or not you can unload this module. If it's in use, you can't unload it. Going into some of the configuration methods, some of the configuration APIs. This is config.h. 2 main ones: load a config file, destroy a config file, category browse, variable browse and variable retrieve, and a little caveat on the category pointers. They are special. because in several of the config files you can have, for example, in sip.conf or eeks.conf, you can have a type user and the same context name that is, for example, a type equals peer. I won't go into type and peers right now because they're irrelevant to my talk. But basically what would happen is, the thing about the category pointers, when you do a category browse, the previous right here needs to be the actual pointer of the last time that you called AST category browse. If you didn't do that, you would go through here, you would get the VCCH, this one, and if you just passed back a character string, and if that worked, you would go down here, and this would be your next one that you'd parse. Now, if there's anything down here, there'd be a problem, because you'd pass back VCCH again, and it would find this one as the first one, and give you this one again. So you'd have a nice little infinite loop there. That's why we have the category pointer is special in the category browse right here. And also the same thing when you do an AST variable browse. Again, that has to be the same physical, the actual pointer, not a copy of the string. Ditto for AST variable retrieve. Otherwise, you'd only ever encounter this one. And then we also have AST true and AST false. The reason for these is that you will typically recognize when you're doing true-false, there are different ways of expressing true-false. There's, of course, 1 and 0. There's T and F. There's the word true and the word false. There's also yes, no. And when you're dealing with the Asterisk config files, you're going to deal with all these possibilities in the config. So the nice thing, we have nice little functions for you to know which is what is actually true. Actually, I've never seen AST false used in code. Everybody either uses true, and then if not true, something else. And then the only two, this AST variable, when you get back for variable browse or for variable browse, you'll get a structure, and the only two that really matter to you are the name and the value. I'm sorry? The question is, what do you get to deallocate those when you're done with them? And the answer is no. Asterisk takes care of that for you. When the channel is destroyed, it goes through and deallocates all of them for you. And here's a few special functions that you, these are not all of them, but a few special functions which you will need to use mostly for portability's sake. Those of you who are familiar with Linux programming will recognize strdupe, which is very similar to an strdupe, except that it uses alloc for its memory allocation. Now, the difference being malloc, which is strdupe, uses memory off the heap. strdupe uses memory off the stack, and so it's automatically deallocated when you return from your function. The problem is that strdupe is Linux specific. It does not exist on BSD. So we have this handy dandy function here to do an strdupe if you're on Linux and do something different if you're on BSD. So it works the same. ASD strlen 0 is something that we added for a very simple reason. a lot of people, myself included, would do in their code, they would do if strlen some pointer. And this is incredibly inefficient because what strlen does is it counts the number of characters in the string. Well, if you're using this as a Boolean, the only thing you really care about is whether the first one is a null or not. So that's why we would modify this in Asterisk to if if not strlen 0 with a pointer. Just a time-saving function that's in there. And we like putting it everywhere because people forget. Again, all these are for portability. AST mutex defines static for a mutex name. This is because mutexes are defined differently on different implementations of Linux and BSD. Some of them you can use as static initializer like in Linux. Others you have to call a function to allocate a number of different structures for initializing the mutex. Get host by name. The usual get host by name is not thread safe, so that's a nice thread safe implementation. Again, with inet n2a, it's not thread safe, so we have our own. And this one, strk string, is another one like strdupe, in which case strk string exists in Linux even though there is no man page for it, but does not exist anywhere else. And the reason I found this out is I actually wrote this function because I went, hey, this would be a neat function to have. And then Mark said, hey, it's in the include file. So I guess it does exist in GNU libc, but it's not documented anywhere. And we found a nice little bug in it too. So that's why it's not documented. All right, so here at this point I will have a bit of a discussion about some applications which I have written. We'll start with say Unix time, cut and eval, and then go into AppStack. All right, so this actually is a copy off of our production machine, on which I do most of my development. Yes, I know I do development on production. It's great, isn't it? So we'll look at So look at, say, Unix time, for example. This is something I wrote from the ground up. Well, that reminds me, that's another function I have that, oh well. It's another function that doesn't exist anywhere else. It's, find it. Let's see, where did I put that? That's right, and this is in subfunction. Never mind. Alright, so this is something that originally there was something in Asterisk called datetime that didn't quite work, or it worked, but it didn't say time in the regular format. I think it said the year before it said the time, or something. Or no, it said the time. It had said the year after the time, so it was really weird. So what I did is I developed something in here that allowed us to say the time in whatever format. And the really nice thing about this is two things. You'll note that in here, not only do you have the choice to say the current Unix time, which if you specify this with the first argument missing, it will say the current time, but also the time zone, which allows you to say it not just in the time zone in the current machine, but any time zone. And the reason why this was problematic was that the functions that we use to parse out the Unix time into its component pieces, the month, day, year, hour, minute, and second, is kind of thread safe. You may notice local time underscore R is what you usually use for that. It's kind of thread safe because you're passing all parameters. Unfortunately, it isn't really thread safe. And the reason is that it uses an environmental variable. In a threaded application, you've got one environmental variable for all of your threads. So if you try to change that environmental variable sometime in the middle of doing your local time, something could possibly change. Bad things can happen. So we wrote, AST local time. That's very similar to local time R, but takes an additional parameter, which is the time zone itself. The same thing that you'd have in your TZ environmental variable. And you may note in here, this is actually two applications. It's both say Unix time and date time. The reason being is that since say Unix time did everything date time did, we just said, the heck with it, we'll just scrap date time. So, takes exactly the same parameters, does exactly the same thing. And here's the exec of it. I won't go too much into this other than get time of day, obviously a kernel call. Grab the seconds out of it. Again, we're using AST-strdupe to duplicate our input, which is a void pointer, and we want to make it into a string so that this doesn't give us an error. Well, not an error, a warning. Parsing of our arguments, generally we use strcep, and you'll notice we're using S here, which in this case is an alloc aid pointer, so it doesn't matter that we're being destructive on this because it's on the stack and it goes away when we return from our function, so we don't have to worry about that. Unix time. Format in here, I'll discuss this a little bit when I go over to say.c, but this is a specific format, which is the day of the week, the month of the year, the day of the year, this actual sound, which is in the subdirectory digits, the word at, and then IMP, which of course is the hour and 12-hour format, M, the minutes, and AM or PM. You may recognize these digits from STRF time. That's because we modeled it off of STRF time so that it wouldn't be too weird. And this is something that I haven't completed yet. At the sound of the tone, the time will be exactly. That's what this is for here. And we have our handy-dandy function, AST say date with format, which is the meat of what it actually does, which I also wrote. If you're familiar with Asterisk, though, you'll know that AST say date with format has actually been far expanded from when I wrote it. It now does almost any language, or any language that Asterisk supports. Again, this is more stuff that I've hacked in here that is not yet ready. Again, our standard unload module, load module, description, and use count. Oh, and we also have key in here, and this is the Asterisk GPL key. You're familiar with this if you're a developer already, but if not, all this is a string which says that if you decide to distribute this module, Digim gets to use it for free, with no license restrictions. Let's see. Oh, and the other one, let's see. Yeah, as you can see, these are all the things that were expanded out. I guess I wrote the underscore EN before it was renamed. Lots of different languages. Here we go. So we just run through the format saying times, and like I said, AST local time takes the three parameters, the actual time, the TM structure, and a time zone, so that we can do it in multiple time zones without creating race conditions. Oh, by the way, the reason why we went with a different thing instead of trying to add a lock is that because this is saying words, if you've got a longer format, you could quite possibly lock your lock for 20 seconds. And if you've got multiple people using the system and they all want to use, say, Unix time, you're going to lock people out for a long time. That's why we didn't use a lock here with local time R for the environmental variable, and instead went with our own routine there. So other than that, this is actually a pretty simple routine. We run through all the characters in here based upon the formula of the character, and again, if you add more options here, please try to be consistent with STRF time 3. We got literal sound files. That's not consistent with STRF time. And the various day of the week, month. These are cardinal numbers, which are different from just numbers. This is as in first, second, third, not 1, 2, 3. Year, dealing with, since I wrote this in 2003, it should always be greater than 99, but just in case, we handle it all the way back to 1900. hours. We did we both do Army time, so we can do 0800 hours, as well as doing 8. For those who want Army time, for those who don't want Army time. We have also two extensions that are not in STRF time 3 here. These are just standard. Really, the reason that we did this was so that if you received something an hour ago, it's not going to go ahead and give you the month, the day, the day of the week, the month, the day of the month, and the year. It could say today or yesterday. Pretty simple. And then Mark asked for lowercase q, which is, it excludes the today if it was today. And more good stuff. Anyway. Since it's getting on... Hey, wow, I wasted half an hour already. We'll go ahead and look at AppStack. Alright. And the basic thing of AppStack is... I need to actually get my presentation back because I actually have these points. The reason why I've created these AppStack stuff is so we have some common routines. Now you may know that a lot of people do subroutines already with macro. I like doing this for a couple of reasons. One, I think it's altogether better than macro. There is a case of an exception. If you have an absolute timeout, which is the maximum amount of time that a call can possibly take up, there is a way to catch that exception. But macro does not handle it. Mark said, hey, why don't you handle it? Well, it does its own event loop, and I wanted to use the regular event loop, not have to deal with this in the future. The other nice thing here is that in Stack, we get recursion without having to do the hacks the way that macro does hacks. Macro actually has to store several variables in a private location so it can do proper recursive macros. And the other thing I added as an afterthought was local variables. And the nice thing about local variables is you can set a bunch of local variables in a subroutine. When you return from the subroutine, they disappear. So just like Perl and C, in fact, the variables are modeled after Perl in that if it can't find your variable on the current level, it looks to the next higher level, all the way up to channel variables and global variables. Let's go back here to the code. So we've created a whole bunch of different applications here. Again, this is a single module, but a number of different applications. GoSub and GoSubIf, you may recognize these from BASIC. That's because they're modeled on BASIC. Return, same thing. Stack pop, pop the last return address off the stack and make it go away without returning. Very useful if you're dealing with exceptions and you don't want to return to where you came from. And so set local var. So again, we have synopses, the same thing, and descriptions. basically what I just said. Go sub if, which is based upon go to if, and we're actually using this currently in our current dial plan to set the caller ID based upon which phone is actually calling it. I know we can set caller ID in zapata.conf, but I liked, because zapata.conf is not reloadable currently, I like to have something where I can do these lookups on the fly, and also allows the admins for our customers to redefine caller ID on the fly. Yeah, I use everything in a database, by the way. And basically what I had to do for doing these stacks is I had to modify the channel definition. And what we modified was, let's see. First we have our AST ghost sub stack here, which is how I implement my stack. The context, the extension, and the priority. This is where you return to a bunch of variables and the next in the stack. So we can, obviously this is recursive up to the limits of memory. This down here, AST channel expansion, you can ignore right now because it's not done yet. But basically we just add that in to the channel structure somewhere in here. This is a big channel structure. There we go. There it is. Right there. Just a pointer, null initialized as usual, and then we had to do a couple extra things in the channel itself. I know this is not very modular, but the thing you saw before, AST expansions, we will soon make this all very modular so that we don't actually have to modify the channel definition when we add new features like this. So in the destructor, we have something to destroy the channel, to destroy all possible stacks that we have in the system, in case you exit without returning. Someone hangs up, for example. And that's it. So the stack stuff will all be released on Monday to the Asterisk community. Do I have any questions? I get this really, really bored look on everybody's face. You know, you did not have to stay here for the entire talk. Questions? The question was whether I program everything in C. When I do everything, I know there's something called AGI, which allows you to execute a separate application. Basically, it forks and allows you to run your applications basically any language. I have by and large tried to avoid that because it is forking, and forking is not as efficient as threading. In the case of an application, you're already threaded for every channel, so you're not actually creating anything additionally. You're just executing a function, so it's even more efficient than just adding new thread. A lot of the applications which I've written over time, over the past 2 years, I've been an Asterisk developer, are applications so that I could avoid writing stuff in AGI. The cut application is a great example of that. So is the random application. Say Unix time to a certain extent was so I didn't have to do my own custom Perl app to to say the current time in whatever time zone I wanted. More questions? Cool. I'm done early. Yes. Uh, the question is whether we were going to port to uh, APXS, APR. Um, I actually have not considered that. The modular design in Asterisk right now uh, is very stable already and works very well. No, I actually had not considered that, but um, yeah, I think it's pretty modular already. You don't need to go that route. Okay. Yeah. Yeah. How well does Asterisk deal with modules that go off the deep end? You mean in terms of if it allocates too much memory? If a module decides to misbehave, well, it is in fact it's located inside Asterisk itself, so Asterisk itself misbehaves. The neat thing here is most people run it inside of safe Asterisk, which is a routine that in case Asterisk were to crash, which it doesn't do very often unless someone wrote something stupid, uh, and I've done something stupid before, so uh, I'm not excluding myself in that category. Uh, in case Asterisk does something stupid, it will restart it on the fly. Of course, you lose all the calls that are currently going on, but hey, how else are you going to deal with a crash? Any other questions? I'm sorry? Squealing feedback? All right. That's it, guys.